Today I'm going to teach you about IMFs, or intermolecular forces. They are the forces of attraction between molecules. There are three different types of IMFs. The first one is London, the second one is polar, and the third one is H-bonds. To begin, I'm going to teach you about London. They are weak dipoles created from fluctuations in electron movements, and they can build up to be strong and large molecules. All covalent bonds have London forces, and a covalent bond is a nonmetal nonmetal. Next, I'm going to teach you about polar. Lone pairs are more repelling, which means that they are more negative than bonds, and they can create a negative pole on a structure. All asymmetric structures are polar, and most structures with lone pairs are polar or asymmetric. The two exceptions for this rule are 4-2, which is square planar, and 2-3, which is linear. Finally, I'm going to teach you about H-bonds. H-bonds are a high level of attraction between H on one molecule and the lone pairs of Fn or O on another molecule. And all H-bonds have the trifecta, which is London, polar, and H-bond together. So now I'm going to show you what an H-bond looks like. So if you have H2O, and H3N, the lone pairs from the N would be bonded to the H, just like this. Next, I'm going to show you some examples of IMFs. So here I have a chart, and since I said all IMFs have to be covalent, these are the three covalent structures. So since this one has two bonds and two lone pairs, it's bent or V-shaped, and it would be London because all covalents are London, and then it would also be polar because it has two lone pairs, which means it would be asymmetric. Next, we have Pi3, and this is also London because all covalents are London. And in addition, this is three bonds and one lone pair, so it's trigonal pyramid. And since it has one lone pair, it's also asymmetric, so this would also be polar. And finally, we have H2O. And here we have also London because it's also covalent. And then it would be two bonds and two lone pairs, which would mean that it's also bent or V-shaped, and it is polar because it's also asymmetric.